Untied. Here we go.
Wait, I have a question. In final, even though it's like not your final, it's still not a grade, like when you get the score back.
Is the final the stage test?
We don't take a sage test. Okay, we got to get to this. Now, let's talk about number 18. You guys, the test is multiple choice, right?
All of it?
All of it's multiple choice. So, look at those directions. If it's multiple choice and all you do is circle the correct answer, doesn't matter how you solve it? Doesn't matter. You could backward substitute if you wanted. It's just a test. It's just a number test. Now you guys listen. Just to remind you, I'm going to show you what an augmented matrix is, but then we're going to solve it a little bit of a quicker way. The augmented matrix looks like this. That's the augmented matrix. Not that it's important, but do you remember where we went from here with the augmented matrix?
Row echelon form, this one, and then we had to give 0, 0, then 1, 0. Remember that? It took a while.
That was called row echelon form or Gaussian elimination. If the question were not to solve the system, but to write it as an augmented matrix, then this would be the answer. You guys make sense of that? Okay. If it says to solve and it's multiple choice, then really you can solve it however you want, as long as you get the right answers. Using a row echelon form takes a little bit of time. So how would we solve this normal?
You would get rid of the same things and cancel it out. And then
Okay. So like this equation here and this equation here.
Yeah.
Why those two?
Because you cancel out the
You can cancel out the y's. So if I added these two equations together, you'd get 4x plus 2z is equal to negative 10. That's the result of the first and the third equation added together. Now what? I would multiply the second one not by negative 2. I would multiply it by positive 2. Okay? I would multiply the middle equation by positive 2 so that will cancel out the y variable as well. You're going to get a 4x plus 1x, that's a 5x. The y variable's gone. 2 times 3 is 6. When we subtract that 1z, you get 5z. And then 2 times negative 13 is negative 26. Negative 26 plus 6 is negative 20. Now what? Now we got to do the same thing these two did. None of them really work out super nice. So I'm going to multiply this one by negative 5. I'm going to multiply this one by 2. So I'm going to get negative 20x minus 10z equals 50. And then 10x plus 10z equals negative 40. Z's are gone. I'm sorry, I'm going so quick, but got to get through this. X equals negative 1. Yeah.
Why did you tell me by 2 instead of not negative?
Which one?
At the very
Because I was multiplying the y to try to get that to be a negative 2, so it would cancel with that 2 right there.
Oh, I thought you were counting.
I was canceling with that one. Does that make sense? Okay. Now where do we go from here?
Plug it in.
Plug it into where? One of the ones above here. You can't go right to the beginning yet, so I'm going to take this and plug it in. Well, not to one of those, to one of these here. So let me choose this one. If x is negative 1, we get negative 4 plus 2z is equal to negative 10. Add 4 to both sides and get 2z is equal to negative 6, which means that z is equal to negative 3. So now we have 2 of them. By the way, just by way of trying to save you time,
As soon as you get your first answer, negative 1, I would check your answer choices. If only one of your answer choices has x equals -1, that's your right. You understand what I mean? There's some, on a multiple choice test, there are ways that you can.
Or you could backwards substitute all your answers. That usually takes a little bit longer, but anyway. So once we have z and x, we can go back and find y. So I'm going to choose the top equation. If x is -1, we don't know y, but we know that z is -3. -1 plus 3 is 2, so we have 2y plus 2 equals 6. Subtract 2, we get 2y equals 4, so y equals 2. Now, had we been allowed to use graphing calculators during the 1050 part, who has a graphing calculator? You can use it for the last half of the test. You can't use it for the first half, but for those that are interested in a cool little thing here, check this out. Try to follow this here. Your calculator can solve matrices like this or systems of equations in about 10 seconds. Okay, if you know how to type it in. So if you hit second and then this little x to the -1, it brings you to the matrix menu. Okay, you need to edit the matrix. So I'm going to go into the edit mode. Now what you need to do is turn this right here into an augmented matrix. So that would be a 3x4 matrix. Now you would put in all the entries. 1, 2, -1, 6, 2, -1. I know I'm going real fast, but you guys understand what I'm doing here? What am I forming here? The augmented matrix.
Wait, could we do this on the test with the calculator?
If it's on the calculator section. So now I've entered the augmented matrix, right?
Yeah.
So now I'm going to quit out of that, go back into the matrix menu, go over to math, scroll up to where it says RREF. That stands for row reduced echelon form. That's kind of like what we do with augmented matrices, right? So I'm going to enter on RREF, and then you need to tell it which matrix to do it on. I'm going to tell it to do on matrix A. Hit enter. You see that?
Awesome. Do you guys understand what this is telling you? Yeah. This one means that x equals -1, y equals 2, and z equals -3. So it can go pretty quick if you know how to use it.
Okay, moving on, number 19. This is one you're going to want to pay attention to, because it's something we learned, it's just slightly different than how we learned it. So 3 teams participated in the competition. Final scores are right here. Team 1 had 3 first places, 5 second places, and 4 third places. Do you understand how I'm reading this? Team 2 had 5 first places, 2 second places, and 5 third places, and so on and so on. What they're interested in here is what was the final score of each team. Now, teams earned 6 points for first place, 5 points for a second place, and what was it? And 4 points here for a third place. Organize this information into a matrix B. First, second, third. First place got how many? 6 points. Second place got 5. And third place got 4. Now, we are going to have to multiply these matrices together, and here's why I specifically made this column matrix and not a row matrix. Okay? This was a 3x3, correct? What's the size or the dimension of this? It's 3x1. Had I turned this around and made the matrix like this, then that would have been a 1x3, right? This could not have multiplied that. Do you understand? So it had to be a column matrix here. Now that you have these 2 matrices, to figure out the total points for each team, all you have to do is multiply matrix A by matrix B. That was the point of this question. So I know it's been a little while, but to multiply a matrix by another matrix, you have to make sure that the inside dimensions are the same. So this multiplication is possible. And then the outside dimension tells you the size of the result matrix, which is going to be a 3 by 1. So that's just a column matrix with 3 entries, an entry here, here, and here. So where does this entry right here come from? That top entry. Row by column. Isn't this the first row? I mean, there's only one column, but it's the first row, first column, right? So we have to take the first row of matrix A and the column of matrix B. You multiply and add. What's 6 times 3? That's 18. Then you add that to 5 times 5, which is 25, and you add that to 4 times 4. 16. So it's 18 plus 25 plus 16. So that's 18 plus 25 plus 16. So Team A scored, or Team 1 looks like it scored 59 points. Now, this entry right here in the middle, how do we find that result? What's the spot of that entry right there?
Second row, first column. It's the second row, first column. So you need the second row here, and then that column, because there's only that one column. So 6 times 5 is 30. And then you add that, go across the row, down the column. 2 times 5 is 10. And go across the row, down the column. 5 times 4 is 20. So 30 plus 10 is 40. 40, ooh, they got about 1 point. That sucks. And then finally, Team 3, you have to go across this row and down the column. 6 times 4 is 24. 5 times 6 is 30. I think this team might have won. 4 times 2 is 8. Did they? Team 3 got 62 points.
Now again, had this been on the calculator part, you guys, you can go back into the matrix menu, you can edit matrix A, but now matrix A has to be a 3 by 3. You could type in all the entries, 3, 5, 4, 5, 2, 5, 4, 6, 2. And then you can go back and on matrix B, you can edit matrix B as a 3 by 1. Let's call it 6, 5, 4. Then you can multiply matrix A by matrix B, and it gives you 59, 60, and 62. Okay, moving on. I know that was kind of quick with the cat. If you're wondering how I can help you with TIs, I can't help you with Casios. I don't know how they work. I can help you have a TI. I can help you with it. Question 20. Sketch the graph of the ellipse. The problem here is this number needs to be a 1. So how do we do it? Divide by 16. Divide everything by 16. Now we have, in standard form, x plus 3 over 16 plus y minus 2 over 4 is equal to 1. So now we have the ellipse.
First thing I would check, knowing that this is multiple choice, is look at the transformations. Where is the ellipse moved? Where has it moved? To the left 3? Remember, it's inside of a function. And it's up 2. I would look at all 4 answer choices. If there was only one answer choice that's been moved to the left 3 and up 2, doesn't that have to be the right answer? Okay. Now, if there are several that are in that same spot, then you have to consider the size, the orientation, if it's horizontal, vertical. But if there's only one that's in that spot, that's got to be the right answer.
But what kind of ellipse is this? It is horizontal. How do we know that? The largest number. With ellipses, it matters which is the largest number. It's underneath the x variable, so this is horizontal. So real quick, let's sketch the graph. Go to left 3, up 2. There's the center. I would now sketch a real quick new coordinate system centered around that new point, -3, 2. Now on ellipses, the largest value is a squared. So if a squared is 16, that means a is equal to 4. The smaller value is b squared, so that means that b is equal to 2. Since the largest value is underneath the x term, it's horizontal. So starting from your new point, you're going to go out 4. 1, 2, 3, 4. There's one vertex. 1, 2, 3. There's the other vertex. So those vertices go on the horizontal axis. Your b values go on the vertical axis. Ooh, that's a crappy ellipse. Anyway, you get the idea. I know. The idea here is that it's horizontal. Okay. It also says to label the foci. What's the formula? It's very close to that. It's c squared. You got to remember this formula is always opposite of what's here. If there's a plus here, it's a squared minus b squared. Okay? So that means c squared is equal to 16 minus 4, which is 12. So c is equal to the square root of 12, which means that c is equal to 2 square roots of 3, plus or minus, actually, plus or minus 2 square roots of 3. Okay. Question 21, find the standard form. This right here is in general form, not standard form. Standard form would look something like this, where it has parentheses squared with fractions. What do you guys remember about this one? Got to complete the square. Exactly. So I'm going to take the x's and round them together and factor out at the same time. I'm doing a lot of steps together. I apologize, but this is important that we get through this. So if we took the x's and factored out a 4, we would have x squared plus 10x, correct? If we took the y's, what can we factor out of that? A minus 5? That's going to be y squared plus, remember, if you factor out a negative from a negative, you get a plus 6y. And then I'm going to add the 45 to the other side. So we've regrouped and factored out the leading term from each of the similar variable terms. Not yet. We are eventually going to divide by whatever number's here, but not quite yet. We have to complete the square here, and we have to complete the square there. So what value completes the square? Here it would be 10 divided by 2 squared. Yep. So that'll be 25. But it's really not. I know it looks like a 25, but it's really not a 25, you guys. What is this really? This is really 25 times 4. So that's a 100 we have to add over here. Now here, it's going to be 9. If you take 6, divide it in half, then square it, you get 9. But it's really a negative 45 when you multiply it with that negative 5. Well, that's kind of nice. The 45s are gone. So we have 4, and then x squared plus 10x plus 25 factors into x plus 5 quantity squared. And then y squared plus 6y plus 9 factors into y plus 3 quantity squared. That equals 100. Now we divide by this number. Divide by 100. So we're going to get quantity x plus 5 squared over 25. What kind of conic is this? Keep going. It's a hyperbola, yeah? Is all we were supposed to do? Oh, then it says graph. All right. So we've got it in standard form. Again, I would do the same thing I did in the last one. Always check. Follow the transformations. Go to the left 5 and then down 3. If there's only one graph at that spot, that's got to be the right one. But it's always a chance you could be that lucky. Most likely not. So So left 5, down 3. There's your new origin, so sketch a quick axis system. Sketching a hyperbola is much different than sketching
And ellipse, there's a lot more to it.
We need a box with those slanted asymptotes. With hyperbolas, the largest value doesn't really mean anything. Just because this is the largest value doesn't mean it's a squared. It's because it's underneath the positive fraction term. So this is a squared. Did you guys hear what I just said, though? It's not because it's the biggest. Why is this a squared? It's part of the positive fraction. So a equals 5. Oh, man. All right, what does b equal? We have to estimate here.
What's square 20, roughly?
It's 2 squared roots of 5, you're right, but roughly, approximately, maybe 4.5, 4.4. It's not super. Just get it as close as you can. I'm going to say 4.4. Okay. Now, well, if this were on the calculator part, you could just type it into your calculator, square root of 20. And, ooh, 4.5 would have been closer. Failure. Alright, so, which one's which, though? A equals 5. Does it go horizontally or vertically? Where does it go?
It's underneath the x variable, so it has to go on the x-axis. It's got to be horizontal.
So you're going to go out 5 in each direction from your x, your new point here. So going out 5 puts you here and about here. And then this 4.5 is on the vertical axis. So it puts you about here and here. I'm just really going quick here. Once you have those, you sketch the central box. What do you do with that central box? The diagonal lines go through the corners in the center. And it's horizontal, so the two pieces of the hyperbola have to go horizontally on the right and left side. Passing through these vertices, you got to make sure that that passes through.
Such, a real terrible sketch, but
The last thing we would need,
Wait, how do you know if it's
the positive piece is an x piece. So it's horizontal because x is the horizontal variable. Does that make sense? What's the last piece we're missing? The two foci. This formula is c squared equals what? A squared plus b squared. So c squared is going to be 25 plus 20. So c squared equals 45. So that's 3 square roots of 5. Plus or minus. You'd have to place those on the graph. Okay. You guys are making good time. If we can finish this little packet, we can circle back and figure out what we hadn't done on that first packet. Now listen carefully, if we don't have time to finish that first packet, I will finish it on my own with a video and post it to the website, but hopefully we can finish it here. We still have about a half hour. So,
Is there any other weird
there's 35 questions total, and there's only 30 questions on the exam, so this is pretty much what the exam's going to be. So, find the first term, common difference of the arithmetic sequence, whose fifth term is 44, the seventh. Ooh, we did problems like this.
what's that? Yeah, there's some formulas you need to know.
Okay, you guys. Arithmetic sequences are patterned using like a y equals mx plus b type formula. Arithmetic means that it's linear. Knowing that would help us figure this out. If the fifth term is 44, Yep.
If you remember, we did a problem like this. Hey, BJ, do you hear crickets? Yeah, it's still in the bathroom. I drive you crazy? I think it might not.
Are we going hunting later today? I didn't get the memo. What?
So Trent, you had a pretty good suggestion. You could do that too. Well, what were you saying? Exactly. Okay, you guys, listen. If this equation is going to be patterned after a y equals mx plus b, aren't we going to have to figure out the slope? Well, the slope is rise over run. That's the difference in y values divided by the difference in x values. What's the difference in x values if it's the 5th spot to the 17th spot? Isn't that a difference of 12 spots? What's the difference in our two y values here? So this is rise over run. This is the difference in y values divided by the difference in x values. What's 108 divided by 12? So that's our common difference. The common difference between each term is 9.
We still need to find b, so we need to find x1.
Yep. The common difference is 9. Knowing that, think about the spot of the term and the actual term itself as an xy coordinate pair. So the 5th spot being 44 could be thought of as 5, 44, like an xy point. Do you guys see what I'm saying? If we have this equation, y equals mx plus b, and we already know that the slope was 9, couldn't we plug in our x and y values to figure out what that missing value of b is? So plug in a 5 for x and a 44, so we have 44 is equal to 9 times 5 plus b. 45, if you subtract that from 44, you get -1. So the equation for this sequence is 9. Now, I've been using x's and y's. Technically, in sequence notation, it's a sub n equals 9n minus 1. But it's the same thing. X, y's, n, a sub n.
But that's the formula that describes our sequence. Where did the 9 come from? That's kind of like the slope. It's the common difference. Where did the -1 come from? It was kind of like finding the y-intercept of a line, of a linear function. Now that we have the equation, how easy is it to find the first term? Just plug in a 1 for n. 9 times 1 is 9. 9 minus 1 is 8.
So the first term is 8. The common difference was 9.
The whole thing that made this possible, or the only thing that made this possible, was knowing that this was arithmetic. Knowing that this was arithmetic let us know
That it was patterned using a linear function. Okay. What does this mean? What does it look like? Sigma notation. Like this one here. This is sigma notation. So what they're asking is not to add this up, not to find the sum. They want you to represent this using this symbol. You guys understand the difference? Adding this up would be pretty easy. They want you to represent it using sigma notation. So if we start with n equals 1, how many terms up there do you see?
There's 13? 14? We better triple count this. We have 14?
So where does the 14 go? On the top.
Now we need to figure out what the formula is. The formula for this series right here has to go right here. We're adding 2 every time, right? So the formula is going to be a sub n equals 2n, but then what's this little guy right here going to be? The way that I taught this was if this is an arithmetic sequence, meaning there's a common difference you're adding, then this piece right here would be whatever number comes before the first number. What would come before the 5? So that would be 2n plus 3. So that's the formula. Where'd the 2 come from? That's the common difference every time. Where'd the 3 come from? It's the number in front of, it's like the 0 term. Because this is the first term, right? the zero term would be like a y-intercept of a linear function. So
that's all they were asking you to do on this problem, is to represent it using sigma notation. Okay? Now, question 24, this is an infinite sign, right? Infinity. How do you add an infinite number of terms? Is that even possible? Only if it's exponential, but not just exponential. Only if the base of the exponential is less than 1. Because that means every term's getting smaller and smaller and smaller. Eventually, once you reach infinity, you're essentially adding 0 every time, so the sum stops growing. Now, you have to remember the formula. It's not a super hard formula to remember, but you have to go back and look at this 2 or 3 times before the test starts. Did you guys all hear that? You're going to have to remember this formula. It's not going to be provided for you. The sum of an infinite series, if it's arithmetic, or sorry, if it's geometric like this, is the first term divided by 1 minus the common ratio. That's the formula to find this sum of an infinite series, if it's geometric. Well, there's 2 problems here. We don't know the first term, and we may not know the common ratio. I mean, that one's pretty obvious, the common ratio. What is the common ratio between terms? How do we find the first term? You plug in a k equals... Isn't the first term where k equals 1? All right, so that would be your first term. Plug in a k equals 1. What's 2/3 to the first power? So the first term is 2/3. No. It's always safest just to plug in a k equals 1 in there just to figure out what the first term is. I know it's been a while since we talked about sequences, but geometric sequences are patterned like this, you guys. You watching? A sub n equals some kind of a term times the common ratio to the nth power. That's how a geometric sequence is represented using a formula. What do you think R stands for? Another ratio. So looking at our formula, what do we say the ratio is? The common ratio is 2/3 between each term. You're multiplying by 2/3 every time. So the common ratio, if this is a little fuzzy to you guys, I would highly recommend you go back and look through your notes. There are a few sequence and series questions on this test. Okay, the formulas aren't provided for you. You have to know them. You have to know what R is and A sub 1, all this stuff. I'd suggest you go back and take a look. Okay. Well, just plug it into the formula now. 2/3 divided by 1 minus 2/3. R is right there. That's R. So what's 2/3 divided by 1/3? It's 2/3 really multiplied by 3/1. 3's cancel. So the infinite sum of that geometric sequence. Exactly. That means that this sum approaches 2, so it gets 1.99999 with an infinite number of 9s. It just never actually reaches 2. 1 minus 2/3 is 1/3, yeah. You learn a lot more about this in calculus. This is called a convergent series because it converges to a number. Anyway. Ooh, all right, so we've got the trigonometry stuff here. Solve. Oh, man. All right. Solve the triangle. If you're unfamiliar with what that phrase means, you better write this down. Solve the triangle means to find all sides and what else? And all angles. Find all sides and all angles. It would really help, especially since it's been a while, just to draw a triangle. It doesn't matter the size. This is not a right triangle, so just draw some kind of a random triangle. Label the vertices. It says that angle C is 28.8. Do you remember how it was that we had to label these? If I put angle A right here, that determines where side A goes. Opposite. So this has to be 21 opposite there. Side B has to go opposite angle B, so this is 16.7. Now, the reason it's helpful to draw this out is now you can visualize what we have here. Do we have side, 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 angle, side, angle, side, angle, side, or angle, angle, side? Obviously, we have side, angle, side. That's the law of cosines. The side, angle, side case. Side, angle, side is the law of cosines. This formula will also not be provided for you, something you're going to have to know.
Are any formulas
C squared equals A squared plus B
C squared equals A squared plus
squared.
B squared minus 2AB cosine C. That's the law of cosines. Well, that's one version of it. What if it wasn't angle C that we were given? Could we rearrange this however we really wanted to serve our purpose? Anyway. So this is going to give us side C. If you plug in the known values, C squared equals 21 squared plus 16.7 squared minus 2 times 21 times 16.7 times the cosine of 28.8. This would obviously be on the calculator section because you have to use a calculator for this. If you're pretty good at using your calculator, you could type this all in at once as the square root of 21 squared plus 16.7 squared minus 2 times 21 times 16.7 times the cosine of 28.8. So once you got it set up, if you can type it in, it really doesn't take that long to do on a calculator. I'm getting 10.3. Somebody better check that. You got that?
Yeah.
All right, we'll go with that. So side C is 10.3. So, yeah, the thing now is we have to find an angle measure. Could we use law of sines? Remember, to use law of sines, we have to have an angle and a side across from that angle. We have to have that to use law of sines. Or it doesn't work. Do we have that? Do we have an angle and a side across from it?
Yes.
We have angle C and side C, so it's probably going to work here. So we use law of cosines to find the side, but now we can use law of sines to find an angle. So we could say C over sine C is equal to which angle do we want to find? Angle A, so that would be A over sine A. We could use this form of the law of sines. You got to plug in all your known values. So side C was 10.3 over the sine of, oh, where's angle C? Where'd you go? 28.8. That's going to equal side A over sine A. Well, I should have flipped these upside down. It's always easiest if your unknown is on the top of a fraction. It's all right, though. Now what? Not really. I'm going to go ahead and invert both of these fractions just to make this easier. So sine 28.8 over 10.3 equals sine A over 21. Now what? Multiply by 21, take the inverse sine, right? So on your calculator, you type in inverse sine. And again, if you're careful, you can type this all in at once. 21 times the sine of 28.8 divided by 10.3.
Do you have to do that first?
Yeah, to find angle A, you have to get rid of the sine function, so you have to use inverse sine. I'm getting 79.
Anybody else get 79?
No. Can you just add them from here and then subtract them?
Exactly. From here, I wouldn't use law of sines again. It'd take way too long. Now that you know one of the angles is 79.2, how many degrees are there in a triangle?
180. If you already know two of the angles, add them together. Subtract from 180.
So looks like we're getting about 72 degrees, roughly. That's what it means to solve the triangle. Okay, the next question is a lot like it, so we're going to skip it. Ooh, simplify the trigonometric expression.
Simplify as best we can. What do you notice right off the bat? What do you notice?
We can factor out a cosine. That's the first thing I noticed. You factor out a cosine, and you get cosine. Oh, this is an easy one. Cosine squared plus sine squared. How easy could that be?
What is cosine squared plus sine squared?
It's just 1. So this whole thing simplified equals cosine theta. There we go. Yeah, they're going to give you an expression, and then the whole test is multiple choice. So they would give you that kind of an expression, and then give you 4 choices to choose from. You'd have to simplify it as best you can. Yeah. No. Okay, graphing the trig function. First of all, the sine.
There's 2 things you need to know to graph sine or cosine for that matter. Amplitude, period. Good. We need amplitude and we need the period. What's the amplitude?
3.
The amplitude is 3, you guys. The amplitude is 3. The minus sign doesn't affect the amplitude. What does the minus sign do? It starts in the middle and goes down, and then up, and then down, and then up, rather than going up and then down. So the negative just flips it upside down. So the amplitude's 3. You guys, right off the bat, knowing the amplitude, I would check all the graphs, because this is going to be multiple choice as well. If only one graph has an amplitude of 3 that's going down and then up, isn't that the right answer? Just saying, always check for simple things like that before you finish the whole problem. Now the period is 2 pi divided by b. That's the formula. 2 pi divided by b. Listen. Now, b is the number in front of x. It's 1, and then that 1 is being divided by 2, so b is equal to 1/2. So if we divide by 1/2, it's 4 pi. So go out on your x-axis, label 4 pi, there's the period, break that up into 2 pi, then you have pi and 3 pi. Amplitude is 3. So starting at 0, 0, you go down and then up. Okay. So the function would look like that. Just to help streamline your studies, you don't have to worry about a phase shift. Okay. Now, you might have to worry about other functions. What if I erased sine and put cosecant? You'd put your asymptotes here, right? Then you'd flip it. The highest point flips up like that. The lowest point flips down like that. Okay? Cosecant's related to the sine function. If it said cosecant, you would have had to graph the sine function anyway, and then flip it upside down. What if it had said secant? You graph the cosine, and then flip that upside down.
Do you take the original sine graph out?
Yeah, the original sine graph wouldn't be there if it were cosecant. It's just there to help you get the right shape and side. Okay? There is a little bit of this going on the tests. You're going to have to remember these formulas.
I would go back and look at them. They're in chapter 7, I believe, of our textbook.
They're in chapter 7. The sum formulas, the difference formulas, the double angle formulas. These are things you're going to have to know. And it's mostly just knowing the formula. It's not really applying it to solve equations or anything. They're just going to ask you some of these formulas. What's the sine, for example? What was the pattern? Sine, cosine, cosine, sine. That was the pattern. Sine, cosine, cosine, sine. So it's sine alpha, cosine beta, plus cosine alpha, sine beta. What was the pattern for cosine? Cosine, cosine, sine, sine. The pattern for cosine was cosine, cosine, sine, sine.
And the other difference is you change the plus to a minus or the minus to a plus, whatever it is. It's opposite. With cosine, it's opposite.
So this is going to be cosine alpha, cosine beta, minus sine alpha, sine beta. Okay, you guys can go through and fill these in. We really don't have the time to fill them all in right now, but you are going to have to know these. Okay, moving on here. Again, I apologize. I know we're going super quick. Just remembering how you guys did on the Chapter 7 exam. This is something that most of you need to go back and review. Very few of you really became proficient at solving trig equations. At least the first time around. You did pretty good the second time around. This one, for example, how do we solve this? We need to get cosine by itself and then use inverse cosine. We need to get, let me say that again, we need to get cosine by itself and then do inverse cosine. So how do we do that? Subtract 1, divide by 2. Okay, so we have cosine squared of x equals 1/2. There is no unit circle allowed, no. Sorry, minus 1, then divide by 2. Now we have to square root. Okay. So we have cosine of x is equal to plus or minus square root 2 over 2. So there's really two equations solving here. Cosine of x equals positive root 2 over 2, or the cosine of x equals negative root 2 over 2. If you do the inverse cosine in your calculator, inverse cosine of the square root of 2 divided by 2, it's going to tell you 45 degrees, but remember, this is only telling you one of them.
This calculator gives you a function, one input, one output. What are we missing?
Are we going to have a unit circle with us?
No. At least I don't think so. I'll call and ask. Maybe they will let you. You don't really need one for this problem, though. Where else on the unit circle would have a positive cosine? Where else is the cosine positive? You guys think. The fourth quadrant. Which angle in the fourth quadrant resembles angle 45? 315. So this one would give you 45 degrees and 315 degrees. Now, they want the answers in radians because the interval is 0 to 2 pi. So you'd have to convert those into radians. Now, what about cosine equals negative root 2 over 2? This would just be the other two angles that resemble 45 degrees or 315 degrees as referencing. 135 and 225. 135 and 225. Again, those are probably going to have to be in radians.
So we have 1 pi over 4. This is pi 4, 45 degrees. We have 3 pi over 4, 5 pi over 4, and 7 pi over 4 for the radian measures.
Okay. I think we're gonna be able to finish this one. You're gonna have to go back and watch the videos when we get out of here. 51. All right. Write it in polar form. This is in rectangular form, so this is x comma y. Go ahead. R squared equals x squared plus y squared. That's to give you r. How do you find theta? It's the inverse tangent of y over x. Okay, those are the formulas there. What about if it's already in polar form? How do you go back to rectangular form?
R times
X equals r cosine theta. What does y equal? R times the sine of theta. I'm just writing down the formulas here real quick just in case. On 33, write the polar equation in rectangular form. My suggestion would be multiply this by r, multiply that by r. Why would I want to do that? Here we have an r squared, so that turns into x squared plus y squared. What is that going to do here? What are we going to have here, for example? R sine theta. What is r sine theta? That's just equal to y. I'm going to finish this one up on my own, post it. Okay? Friday's the test, you guys. It does go on your grade.
Are you going to finish the first one?
Okay? I'll finish the first one as well.